Welcome to my YouTube channel Program King. And today we deep dive into one of Java's most powerful features, static variables. In this presentation, we'll explore the ins and outs of static variables in Java, uncovering their unique characteristics, real-world applications, limitations, and practical uses. We'll also look at some common examples of static variables found in the Java standard library, so you can see exactly how they work in action. By the end, you'll have a clear understanding of how static variables can make your Java code more efficient and versatile. So let's go. Let's dive into the fundamentals of static variables. A static variable in Java is declared using the static keyword inside a class, but outside any method. What makes it unique? It doesn't belong to individual objects. Instead, it belongs to the class itself. So what does that mean? It means that static variables are shared across all instances or objects of a class. Every single object created from the class uses the same static variable, allowing for consistent shared data across objects. This is a powerful feature that can help optimize memory usage and maintain uniformity in data for all instances of a class. Let's now explore the key characteristics of static variables. First up, memory allocation. Static variables are stored in the static memory, also known as the method area of the JVM. What makes them special is that they are initialized only once, regardless of how many instances of the class are created. This ensures that all instances share the same static variable. Now, let's talk about default values. When a class is loaded into memory, static variables are automatically initialized to default values. For example, numeric types get a value of 0 and booleans are set to false. Next, the lifetime of a static variable. The lifetime of a static variable is different from instance variables. Unlike instance variables, which are tied to the lifetime of an object, static variables are associated with the class itself. They are stored in memory as long as the class is loaded in the Java Virtual Machine, JVM. When the class is unloaded from the JVM, for example, when the application terminates or the class is no longer needed, the static variables are removed from memory. And finally, access. Static variables can be accessed directly using the class name, without needing to create an object. While it's technically possible to access them via an object, it's not recommended, as using the class name improves clarity and readability. In short, static variables are unique, powerful tools that are shared across all instances of a class, and their behavior is closely tied to the class itself. Let's take a look at a practical example of how static variables work in Java. Here we have a class called counter with a static variable count. This variable is shared by all instances of the class, meaning each object of counter will update the same count variable, not a separate one for each object. In the constructor, every time a new counter object is created, the count variable is incremented by 1. So, with every object, we're increasing the value of count, which starts at 0. The displayCount method is static as well, so it can be called without creating an object of the class. It simply prints out the current value of count. Let's break it down. We create 3 objects of counter: obj1, obj2, and obj3. Each time a new object is created, the static count is incremented. So, after creating 3 objects, the count variable has a value of 3, and when we call counter.displayCount, it outputs count:3. If the count variable were non-static, each object would have its own separate copy of the variable. This means that the value of count would not be shared, and it would not reflect the total count across all objects. In such a case, each object would only update its own version of count. And the summary is, this example clearly demonstrates how static variables are shared across all instances of a class, making them an essential tool when you want a variable to be common to all objects of the class. Now let's dive into the limitations of static variables in Java. Explaining limitations 1 and 2. First up, static variables cannot directly access instance variables or instance methods. Why? Because static variables belong to the class itself, while instance variables belong to specific objects. This means a static variable can't directly interact with instance-specific data or behavior. Second, static variables are not subject to polymorphism. If you change the value of a static variable, it affects all objects of the class. This can lead to unexpected behavior, as all instances are impacted by that single change. Explaining thread safety. Next, thread safety. Static variables are often shared across multiple threads in a program, which can create synchronization issues. Without proper synchronization, static variables may lead to unpredictable behavior in a multi-threaded environment. Now let's quickly look at some brief limitations of static variables. Global access risk. Static variables have global access, meaning they can be easily misused across objects. This can lead to confusion or unintended changes in state. Less flexibility. They offer less flexibility, as you cannot customize a static variable's value per object. It's the same for all instances. Increased coupling. There's also increased coupling. Static variables tie objects to the class, reducing modularity and making your code harder to maintain. Memory retention. Because static variables persist as long as the class is loaded, they have longer memory retention. They stay in memory until the program ends, which can be inefficient in some scenarios. Hard to test. Finally, static variables are hard to test. Since they affect the entire class and its instances, isolating changes in unit tests becomes challenging. Summary. In summary, while static variables can be powerful, they come with limitations that can impact flexibility, testing, and thread safety. Use them carefully and make sure they're the right choice for your specific needs. Now that we've covered the fundamentals, some characteristics, one example on static variables and limitations, let's explore some real-world applications of static variables in Java. Introduce database connection pooling. First up, database connection pooling. In large-scale applications, managing database connections efficiently is crucial. Static variables can be used to track the number of active connections to the database. By storing the connection count in a static variable, you ensure that all parts of the program are aware of the current connection status without having to create new instances for each access. Inventory management. Next, in inventory management, static variables come in handy for tracking the number of items available or used in a store. Imagine managing stock across multiple locations. A static variable can keep track of the total number of products in stock, making sure that all systems access the same value, no matter how many users or processes are involved. Caching data. Let's talk about caching data. Static variables are perfect for caching frequently accessed data in memory to avoid redundant calculations. For example, if your program performs complex computations or database queries, storing the result in a static variable prevents the need to recompute the same value multiple times, saving processing time and resources. Shared configuration settings. In applications that need global configuration settings, static variables are often used to store these values. Think of API keys, database URLs, or server configurations. These are constants that remain the same throughout the application, and by storing them in static variables, you can easily access and modify them without passing them through every object. Singleton design pattern. Finally, let's talk about the singleton design pattern. This is a classic design pattern used when you need to ensure that a class has only one instance throughout the application. Static variables are key here because a static variable holds the instance of the class, ensuring that only one object of the class exists, and all parts of the program share this single instance. Summary. As you can see, static variables play an essential role in a wide variety of real-world applications. Whether it's managing connections, tracking inventory, caching data, handling configuration settings, or implementing design patterns, static variables help ensure efficiency and consistency across your program. Let's dive into the key advantages of static variables, represented here in a three-phase triangle. Phase 1. Memory efficiency. First up, memory efficiency. Since static variables are shared among all objects of the class, they consume less memory. Rather than allocating memory for each instance of a class, only one memory location is used for the static variable, making your program more memory efficient. Phase 2. Global access. Next, we have global access. Static variables can be accessed from anywhere in the code, whether you're inside a method, a constructor, or even without creating an object. This makes it easy to maintain and share values across different parts of your program. Phase 3. Constant values. Lastly, constant values. Static variables are often used to define values that should never change, such as configuration settings, API keys, or mathematical constants. By declaring them as static, you ensure that these values remain consistent and unaltered throughout the entire program. Summary. To sum it up, static variables provide memory efficiency, global access, and the ability to define constant values. They are powerful tools for improving the performance and structure of your code. Let's now explore how static variables are used in the Java Standard Library. These variables simplify coding by providing predefined constants and commonly used functionality. Let's dive in. System class. First up, the system class and its famous system.out. This is a static instance of printstream used to print output to the console. For example, system.out.println hello world. It's your go-to for printing messages, debugging, or just saying hello to Java. Math class. Next, the math class. A notable static variable here is mathPI, a constant representing the value of pi. You can use it to calculate areas, like so. Double area equals pi times radius times radius. Mathematics made simple and precise. File class. The file class comes with a helpful static variable, file.separator. This represents the file separator specific to your operating system. For example, string path jar.homegi plus file.separator plus user plus file.separator. This ensures your file paths are platform independent. No more worrying about slashes and backslashes. Integer class. Moving on to the integer class. It offers static variables like integer.max value and integer.min value, which represent the maximum and minimum values an integer can hold. Here's how you use them. System.out, print line open parenthesis, maxint colon space, plus integer.max value, close parenthesis semicolon, system.out print line open parenthesis, minint colon space, plus integer.min value, close parenthesis semicolon. These are super handy when working with numeric boundaries or validations. Collections. Lastly, the collections class. It provides static constants like collections.emptylist, emptymap, and emptyset. These are immutable, predefined empty collections. For instance, list empty list, collections, empty list, map empty map, collections, empty map. These come in handy when you need placeholder collections without any data. And there you have it, some of the most useful static variables in the Java Standard Library. Understanding these can help you write clean, efficient, and platform-independent code. Thanks for staying with us till the end. If you found this video helpful, don't forget to hit the like button, share it with fellow developers, and subscribe to our channel for more exciting content. Stay tuned, because your learning curve just got a lot more exciting. See you in the next video. Thank you for watching this video on Program King. If you found it helpful and informative, please give it a thumbs up, share it with your friends, and leave a comment below with your thoughts or questions. I'd love to hear from you. Don't forget to hit the subscribe button and turn on the notification bell so you never miss an update from Program King. Together, let's continue exploring, learning, and mastering the world of programming. Thank you for your support and see you in the next video. Happy coding!